our second contest called HackAtom. Let me open the event. And first of all, I would like to welcome everyone who joined this unusual event today. I would like to welcome our guests from Russia, who are quite away now from here. I would like to welcome our respectful jury, who will judge tomorrow the work of all the contestants. And I also would like to welcome the participants, the teams who will compete today and tomorrow. And finally, I would like to welcome audience and the organizer of this event, Icona Communications. I would like first of all to present myself. My name is Plamen Petkov. I work in Sofia University. I'm associate professor there. And this is the second year when I will moderate this contest. We organized this contest last year. This is the second year, consecutive year. And I hope that this year was the same successful like it was like the last year. So where from comes the name HackAtom? HackAtom is derived from the traditional computer contests called HackAtom, where people contested doing computer programs. So we modified this contest and make it appropriate and typical for the unusual topic like nuclear power. Everybody knows that nuclear power is the highest technological way of producing electricity. And in these ways of the increasing of pollution and of the world, it takes more significant place, I would say. So our initiative takes part in the cooperation of Sofia University, Technical University of Sofia. Technical University, can you hear me? Is there somebody from Technical University?
Yes.
Okay. Uwe Kind International School in Sofia. Uwe Kind, can you hear me? Somebody from Uwe Kind. Yeah, they can hear me. Professional School in Nuclear Energy from Kozloduy. Professional School, can you hear me? Yeah, they answered. So this is the all institutions that participate in this team. So I would like to present the agenda of the event. The event will be organized in 2 days. During the first day, there will be some lectures from the leading Russian scientists. They work in the nuclear field and work in leading Russian universities. After that, Dmitry Samokhin. Dmitry, hear me now. Can you hear me now? Okay? Dmitry Samokhin will present the tasks which students
I hear you. Thank you. I hear
okay,
you.
which the student can solve for 2 days. Second day will be dedicated to the presentations of the teams. So, jury is made from 2 Russian professors and 1 Bulgarian representatives. Alexander Nakhabov. Alexander, can you hear me? Okay, hello. Dmitry already answered. Mladen Mitev, chairman of Bulgarian Nuclear Society. Mladen, are you here? Still can answer. Okay. Who will participate? Who will take part in this event? First of all, Department of Physics in Sofia University, jointly with the Department of Chemistry in our university, will participate in 2 teams, together with the high school students of Huvekind International School. Also, the Department of Heat Power Engineering in Nuclear Energy of Technical University of Sofia will participate with 2 teams. And 1 team from the student of the high school student from the Professional School of Nuclear Energy, Igor Kurchatov from Kozloduy. I would like to now introduce, to remind the requirement of our competition. Official language will be English. Each team will be made up to 5 students, no more. They are allowed to be less than 5, but no more than 5 students. Each team decides how to work, offline or online. When choosing to work online, okay, they can distribute and decide which platform to use. If decide to work offline, they also select the place where they can work, following the rules against, of course, COVID-19. So there are no restrictions that each technology can be used. Everybody can decide what kind of technology to use, and the number of participants can decide how to distribute a report of their solution, and they will have 25 minutes to present their project. After that, they will ask by the jury some questions, and they're supposed to answer to these questions. I just would like to bring to attention to the teams, each team works separately, each team works independently. This is because the idea is to increase to our joint work, friendship between the students, to create more compact and tight the connections between the participants of each team. The prizes, the winner prize, each participant and team that wins will receive, like us here, last year, electronic reader. And every participant, like the last year, will receive voucher, electronic voucher to buy a book in Bulgarian store. It was like similar like the last year. The prizes come from the Russian State Atomic Corporation, Rosatom. So I would like to say a couple words to thank about the sponsor who support today's competition and help us to initiate this initiative. So let's start with our first day, which is our days of the lectures. First lecture will be Doronkov Denis Vladimirovich. He is the lecturer of the Department of Nuclear Reactors and Power Engineering at Nizhny Novgorod State Technical University. Denis, can you hear me?
Yes.
Okay, microphone is yours. Let's start with your presentation.
Good day, dear friends. My name is Denis Doronkov. I am a senior lecturer at the Department of Nuclear Reactors and Power Plants, the Nizhny Novgorod State Technical University, named after Alexeyev. I would like to talk about Russian innovative small and medium reactor plants and innovative technologies in nuclear energy. The ensure the sustainable industrial development and to successfully solve social issues in the regions with decentralized power supply, safe local sources of electricity and heat are necessary. One of the solutions for this problem is to use small and medium-sized nuclear power plants. The major advantage of the marine technology-based small and medium-sized nuclear power plants are compact size that allows the plants to be sited in remote regions and on limit areas, a possibility of creating for the small and medium-sized nuclear power plants the required power depending on the customer's requirements through selecting the number of models, which reduce the construction costs and time. A short construction time of the small and medium-sized nuclear power plants as compared to a large power facility. With the use of reference marine reactor operation processes, the operator does the fuel handling, proves the proficient maintenance and plant decommission after the plant lifetime is over. Next slide. Giant stock company HackAtom OKBM is a chief designer and manufacturer of reactor plants and a complete supplier of marine proposition plants. Currently, giant stock company HackAtom OKBM is developing land-based small-sized nuclear power plants incorporating the Rhythm 200N reactor and floating small-sized nuclear power plants incorporating the Rhythm 200M reactor that are based upon the marine Rhythm 200 reactor technologies. 6 Rhythm 200 reactors are installed on the multipurpose nuclear icebreaker, Arctica, Sibir, Ural under construction. The development of the small-sized nuclear power plants is based on the experience of developing operating the reactor plants for the Russia icebreaker fleet. The small-sized nuclear power plants incorporating the ABV-6E reactor plants has been developed in 2 options. A floating version based on the floating power unit FPU Academic Lomonosov for floating nuclear cogeneration plants FNCP in Pevek at Chukotka Autonomous Okrug, Russia. The floating power unit is a non-self-propelled moored vessel that is towed to its operating site by a water route. On the operating site, the floating power unit is connected to the coastal structures that transfer heat and electricity to the consumers. A land-based version with a modular transportable power unit MTPU that includes the reactor plants and is installed on a coastal territory. The basic conceptual solutions for the ABV-6E reactor plants are natural circulation in the steam generating unit, safety based on passive system. The land-based small-sized nuclear power plant incorporating the ABV-6E reactor plant is a power source fitted with land-based modular transportable power unit and equipment to load and unload the models. The advantage of the modular transportable power unit for the small-sized nuclear power plants based on the ABV-6E reactor plants are that the protective waterside structures and special devices to transmit power to the shore are excluded. There is a possibility of setting the small-sized nuclear power plant far from water sources. The ice and tsunami protection is excluded. The modular transportable power unit has small overall dimensions and weight compared to a floating power unit. This is what the floating power unit Academic Lomonosov looks like within the floating nuclear cogeneration plant in Pevek, Chukotka Autonomous Okrug, Russia. The floating power unit, which is the main component of the floating nuclear cogeneration plant, incorporates 2 reactor plants. The plant is an upgrade on the reactor plant used in the operating nuclear-powered icebreakers and in the light aboard ship Thermopylae. The design of the floating power unit Academic Lomonosov, incorporating the KLT-40S reactor plants, is operated in conformity with the Russian Federation regulatory documentation for nuclear ships and floating structures, as well as with account of the IAEA recommendations. In 2009-2011, Joint Stock Company AKBM Frikantov, along with its constructors, delivered to the shipbuilding company, where the floating power unit was being built all the equipment for the two reactor plants in the scope established by the contract. In early 2018, the construction activities were completed on the world's first floating power unit, Academic Lomonosov. In 2018, the first critically was achieved in the reactor of the nuclear power system. In 2019, the floating power unit approval testing was completed in Murmansk, Russia. In 2020, the floating nuclear cogeneration plant based on the floating power unit Academic Lomonosov was put into commercial operation. Currently, the floating nuclear cogeneration plant supplies electricity to an isolated grid of the Chaubilibino generating system at the Chukotka Autonomous Okrug, and it's assumed the heat will be supplied starting from the summer of 2020. The small-sized nuclear power plant has the following design options. A land-based small-sized nuclear power plant incorporating the Rhythm 200N reactor plant. A floating small-sized nuclear power plant incorporating the Rhythm 200M reactor plant. The land-based version of the small-sized nuclear power plant incorporating the Rhythm 200N reactor plant is designed to generate electricity. Additionally, a possibility has been provided for fitting the small-sized nuclear power plant with district heating and desalination plant if necessary. The small-sized nuclear power plant includes the following buildings and structures. Main building, special building for 2 units, pump station for supplying service water to the turbine building, administrative and living quarters unit, another. The main building incorporates a reactor unit, turbine unit, engineering system units. As a power source for the small-sized nuclear power plant, the Rhythm 200N reactor plant is adopted. The accomplished studies have shown that the marine reactor plants, thanks for their specific properties, enable the small-sized nuclear power plant to achieve the highest technical and economic performance and effectiveness. The design of the small-sized nuclear power plants incorporating the Rhythm 200N reactor plant conform to the world's requirements and trends in the sphere of nuclear facility safety. One of the phases in developing the power sources based on the floating power unit Academic Lomonosov is a floating version of the small-sized nuclear power plant design incorporating the Rhythm 200M reactor plant. The optimized floating power unit with 2 unified reactor plants for the non-self-propelled version of floating nuclear power plants is a moot vessel analogous to the floating power unit Academic Lomonosov, which has the nuclear power system incorporating the Rhythm 200M power plants installed on it. The key optimized floating power unit advantage that determine its economic efficiency and competitiveness are the enhanced electric power and the long operating period without any refueling at an entire life cycle of 60 years. The unified basic engineering solutions and equipment of the nuclear power system and of the entire floating power unit. The floating power unit operation of issued without refueling and the operating site until a factory repair. The main equipment used on the written 200M powered floating power unit has production proven and operation proven prototypes, and it may be manufactured by Russian companies. The accomplished optimization activeness allowed the capital and operation costs to be considerably reduced and the economic efficiency of the plant to be enhanced. The VBR 600 reactor plant, designed on the basis of modular marine pressurized water reactor, allows it to be used in medium-sized nuclear power plant to provide heat and electricity to the regions that do not have centralized power supply. It's also provided for that the power unit be used as power sources within seawater desalination complexes. The major advantages of the VBR 600 reactor plants: the engineering solutions for naval and marine reactor plants, compact modular layout the reactor unit, the main equipment that does not require the auxiliary systems be in operation, leak-tight reactor coolant system, a possibility for the reactor control to the maximally automate VVR technology. The power unit incorporating the VBR 600 reactor plants has the following technical and economic characteristics: thermal power 1662 megawatts thermal, electric power at least 615 megawatts, a site service life 60 years. The VBR design solutions allow a wide power range of reactor plants to be developed on the basis of unified equipment to satisfy the entire spectrum of the expect regional demand. The VBR reactor plant designed under development have a high level of reference and cover the unit power range from 325 to 615 megawatts electrician because a loop type layout is used. General characteristics: the designs ensure high technical and economic performance and referencing in the used engineering solutions. Their safety is comprehensively validated and verified by the many years of successfully operating analogs and prototypes. The reactor plants for small and medium-sized nuclear power plants meet all the world's state-of-the-art requirements and trends in the sphere of nuclear facility safety. The written reactor plants have advantages in terms of safety, mass and size characteristics, and technical and economic performance. Now I will tell you about Nizhny Novgorod and the Nizhny Novgorod State Technical University named after Alexeyev. Nizhny Novgorod is an important economic, industrial, scientific, educational, and cultural center of Russia, the largest transport hub and administrative center of the Volga Federal District. The historic part of the city is rich in attraction and is a popular tourist destination. In short, Nizhny Novgorod State Technical University, named after Alexeyev, is located in the beautiful city of Russia. Our university is one of the leading technical universities in the Volga Federal District. Nizhny Novgorod State Technical University occupies a leading position in the training of engineering personnel for the enterprises of the nuclear industry. The university is a member of the Association Consortium of Flagship University of the State Atomic Energy Corporation Rosatom, and is one of the base universities from the Russian Federation in the IAEA regional network, education and training of specialists in the field of nuclear technology, StarNet. The university has 7 institutes in different areas of engineer training, including training for the nuclear industry. They are listed on the slide. These are nuclear technologies, electric power engineering, transport system, radio electronics, chemical technology, and metallurgy. As a result, Nizhny Novgorod State Technical University implements about 30 areas of training and specialists one way or another, preparing engineers for the nuclear industry, including for the enterprises of the State Atomic Energy Corporation Rosatom. At the moment, Nizhny Novgorod State Technical University has signed and is successfully implementing agreements with many foreign education institutions, scientific organizations, and industrial enterprises and corporations, including the presence of China, European Organization, Asia partners, the United States of America, etc. Thanks to this agreement, students and trainees from near and far abroad are trained at Nizhny Novgorod State Technical University. Foreign students are very interested in the authors' courses prepared by the leading teachers of Nizhny Novgorod State Technical University. Last year, in cooperating with the Technical Academy of Rosatom, Nizhny Novgorod State Technical University implement a project to prepare the short-term courses and a full-fledged master's program on the subject of small-sized nuclear power plants in English. Today, it's believed the small-sized nuclear power plants with small modular reactors are the most efficient option of the development of energy in the area of decentralized energy supply. This option ensures energy security, the solution of major socio-economic problems, and the development of remote areas. Therefore, the demand for specialists in this area of knowledge is extremely high. The Nizhny Novgorod State Technical University and Technical Academy Rosatom project consists of 2 parts. First, this is a program of additional professional education, nuclear power plants with small modular reactor, main aspects and life cycle, a new educational product aimed at improving the qualifications of specialists from foreign partners countries in the field of nuclear power plants of small and medium power in the amount of 72 hours. Second, as well as a 2 years master's program whose graduates are preparing for research, design and development activities in the field of nuclear energy, including on the subject of nuclear power plants, have the necessary skills to analyze project documentation. The topic of study of the master's degree programs are focused on innovative approaches in the design and construction of nuclear power plants, methods for solving engineering problems in the design for power plants, principles of nuclear power plant safety assurance, organization of a thermophysical experiment, organization and conduct of scientific research, modeling of heat and mass transfer processes for the creating of power plants, hydrodynamics and heat transfer in equipment of nuclear power plants, meteorological support of thermophysical experiment, Rosatom production system in the design and construction of power plants, economic evaluation of the efficiency of decision-making in the energy sector, tribological aspects of the design and construction of power plants. It should be noted that for many years our university has been implementing the education through science program. Through this program, all students and masters have the opportunity to gain experience and work and operating in unique research facilities. Basic laboratory Africant of OKBM reactor hydrodynamics, where research is carried out which the aim of optimizing the design of promising fuel assemblies for nuclear reactors and increasing their unit power. A multipurpose high-pressure open-loop aerodynamics test facility with an air coolant allows you to carry out the following types of work. Substantiation of structural elements of nuclear reactor by conducting research work on the study of hydrodynamics and mass transfer of the coolant. Creation of a database for experimental data for verification of programs for three-dimensional thermal hydraulic calculation. Today, this scientific laboratory is conducting research on the hydrodynamic characteristics of individual elements of fuel assemblies for small modular reactors for small-sized nuclear power plants. On this site, you can see part of the results on the distribution of axial velocity in the fuel assemblies of the written type reactor. Large-scale test facility for research on the hydrodynamics of the coolant flow in the main equipment of nuclear power plants with an electric power of 1.5 megawatts allows you can carry out the following types of research. Investigation of mixing processes of isothermal and non-isothermal coolant flow in nuclear power plants equipment. Studies of the thermal hydraulics of the coolant flow in the main and auxiliary equipment of the nuclear power plant. Verification of calculation programs, software package for three-dimensional modeling of thermophysical processes, clarification of the physical and mathematical models embedded in them, justification of the calculation methods used, research of thermal, hydraulic, and resources characteristics of high-stress heat exchange elements, studies of unsteady heat transfer processes accompanied by temperature pulsation in the flow and elements of the heat exchange equipment of the nuclear power plants, modeling of temperature fluctuations to substantiate the research characteristics of heat exchange equipment. Nowadays, Our scientists using this experimental setup are investigating the features of the coolant flow in a small modular reactor for small-sized nuclear power plants and a new generation icebreaker. On this site, you can see beautiful landscapes of Nizhny Novgorod. There is a Nizhny Novgorod Kremlin, the Chkalovskaya stairs, and the main football stadium. Our university is ready to provide students with comfortable rooms in the modern campus. The close geographical location of Nizhny Novgorod and Moscow makes it possible to quickly transfer to our city. Just 3.5 hours by train or 1 hours by plane, and you will find yourself in Nizhny Novgorod. Taking a moment, I would like to note that this year Nizhny Novgorod celebrates its anniversary, 800 years from the date of its foundation. We have a great history and we have something to show everyone. Thank you for attention and welcome to Nizhny Novgorod.
Thank you very much. Thank you very much, Denis. It was very nice, very interesting presentation. Now it's open for questions. Please, audience, teams, ask questions. You can type your questions on the chat, or if the microphone is allowed, just ask questions.
Hello, can I ask a question?
Yes, of course, please.
Yeah, so about the moving power plant, the ship, does it have propellers by its own, or it requires a towing station or something?
Denis?
Can you repeat, please?
Sorry, so the moving power plant, the ship, does it have an engine that it can move by itself, or it requires something to tow it?
Denis, it does not have engine.
I understand, okay.
Other questions, please?
It's transport by another ships.
Yes, I understand.
There's a question on the chat from Ivan Tikleev. Question is, because this solution, small transportable reactors, is applicable for huge country like Russian Federation, but is also appropriate for the worldwide applications to small countries like Bulgaria. Actually, I also wanted to ask this question. What's your opinion about this?
It can be used in the world.
Yes, possibly it would be used, but question maybe is more specifically directed, would be profitable this use? Do you have some analysis on this? Or you have analysis for Russia, which is the huge country? But maybe we can discuss this later, of course, if we have time.
We did not have analysis.
Okay, thank you. Other questions? Question from Adrian Belichinov. You mentioned protection against waves. Can you give specific examples about waves protection on your floating power plant?
One moment. Installation of breakwaters. It can be an example.
Okay, thank you. I see, there's another question from Vladimir Tekliev. Would this kind of floating power plants be applicable for countries with no access to sea or ocean? Or it just required ocean?
No, it can be used.
Okay. It seems there are no other questions. So let me ask you one question, final question maybe, and to close this discussion. So you mentioned the technology of transportable nuclear reactors, and we all know that Russia has two directions of this technology. One direction is, I say, above the water, which is dedicated to thermal neutron nuclear reactors, started from icebreaker Lenin, like 60s. But there's another technology, you also mentioned about this, which is go underwater, start from underwater, from Russian submarine, known like Alpha class, which are fast neutron reactors. And when this project was kept in secrecy until 1997, and when they was revealed, the entire world was inspired about the Gen 4 nuclear reactors because they provide enhancing safety compared to thermal nuclear reactors. My question is, which direction you like more? The direction of the thermal neutron nuclear reactors for the icebreaker and the floating nuclear power plant like academic Lomonosov, or fast nuclear reactors, which is designed for submarines and possibly for Gen 4, future Gen 4? Which you personally like more and you prefer?
I like a nuclear reactor for submarines.
Okay, thank you. Thank you very much. So let's close the discussion. And I think let's start to the second lecture. The second lecture will provide lecture and ensuring the safety of nuclear power plants with VVERs. I would like to just to say a few words about this. The safety is very general term, and it is very important to provide safety of the nuclear energy. So please, I give microphone to Dr. Mikhail Kuznetsov. Mikhail, please, microphone is yours.
Yeah, thank you very much. Yeah, you're right. The safety principles, the safety insurance is very important for big energy nuclear reactors. And I greetings you from Tomsk Polytechnic University. It's one of the oldest technical university in the Asian part of the Russia. And let's start with our presentation. So, VI technology is one of the most interesting and important for state corporation Rosatom now, and in the present time we realize a lot of such projects not only in Russian but actually abroad, in India, China, Bangladesh, and in Europe too. And I want to talking about some safety system, maybe some specific features of VVR technology, just because this installation is very difficult, and we can't cover all safety system during half hour, but I think we talk about the main. And the main part of the VVR, the nuclear reactor VVR, which you saw on the slide, is nuclear reactor for heat exchangers, main circulation pumps, pressurizers, and so on and so on. And according to the safety, we must guarantee the reservation, and we must guarantee the set of equipment which continue the cooling of nuclear reactor, control the reactivity parameters of the installation, and of course prevent the spreading of radioactive substances during different accident and incident. And VVR nuclear reactor is pressure light water reactor. On the slide you can see the main parameters of VVR 1000. The electrical power is about 1 gigawatt, and thermal power, nominal thermal power, which can operate VVR, is 3,200. But now we already realized more modern installation, VVR 1,200, and the main technological parameter presented in the table. The nominal pressure is about 16 megapascals. Temperature drop from 298 to 329. You see the increasing temperature in nuclear reactor core only 18 degrees centigrade, but this temperature increasing is enough to guarantee the efficiency of NPP with nuclear reactor VVR more than 30%. The main geometrical parameters are present on the slide, and you see it's very complex and big installation, and we must guarantee the safety, especially after accident in Japan. We increase the safety, increase the number of the safety system in our VVR technology nuclear reactor, and one of the main safety parameters you see in the last line of the table, that control and protection system drop time in nuclear reactor core, it's no more than 4 seconds. That means under the atmospheric pressure, according to the physical parameters, according to the physical principles, the emergency control rods will be put in the nuclear reactor core and stop the fission process. It's one example of the safety system for our nuclear reactor, which guaranteed that nuclear reactor will be stopped during some accidents. Now let's talking about some basic principles which realized in nuclear reactor VVR type. And difference and depth is one of the basic principles if we want to guarantee the safety for personnel, population, and environment. And the first level of the safety is choosing the NPP conditions, the place, situation, and during the finding the appropriate place for nuclear power plant, we must take into account the climate properties, the economical properties, social activities, geological behavior, and so on and so on. Know all parameters of the nature, wind resources, water resources, and so on and so on. And we must prevent of operational disruptions and so on due to nature, economic, or social parameters. So the next is we must prevent designed by this accident by normal operation system. That everything happened during the operation, and if accidents happen, our normal operation system must cover it, and without any reactivity change, without overheat of the nuclear reactor core, and safety, the normal parameters, normal regimes of the nuclear power plant, and of course to prevent the spreading of the nuclear or radioactive substances. Third level is prevention of beyond design basis accidents by safety system. You know that during preparing the project of any nuclear reactor, we must take into account different accidents and incidents, which is covered by project and which is out of the project, and usually we call this the beyond designed basis accidents, but we take into account the statistics, different initial conditions which must be taken case and covered by safety system, such as melting of the nuclear reactor fuel, spreading of radioactive gases and substances under the containment, and so on. We will talk about different safety systems which prevent all these incidents, and how we will localizing this this accidents. So the fourth level is beyond design by this accident management, and we must be ready to operate the nuclear reactor and PP in common during the design by this accidents and prevent spreading of nuclear material and radioactive substances. And of course, the fifth level, it's emergency planning. You know that even each industry, each installation, even in our universities, we must plan. We must have plan for any emergency chances. That's why nuclear power plant must be ready for different cases. So, in any case, according to the IAEA classification, our nuclear reactor must control and cover three main ways of three main changes of the safety. First of all, we must be ready to control the criticality and the neutron physical processes in nuclear reactor, and we must be ready to transform it to the subcritical state and provide the procedure of the shutdown of the nuclear reactor. After shutdown and transforming the nuclear reactor in the supercritical state, we must provide the co-cooling system and provide the removal of the residual heat from the nuclear reactor, and not only from nuclear reactor but also from the spent fuel pool, which is stored under the water, and we must provide the cooling of this pool too. And the third one, we must control the concentration of radioactive substances under the containment and prevent spreading of it by active and passive safety system. The next one of the most biggest slide. Which principles lies in the project of nuclear reactor technology? So we based on the main principle that all safety systems must have several channels. Each of them must be undependable and covered their functions in different cases. For example, one channel is broken, another under repairing, and your two channels must guarantee the cool down of the nuclear reactor core, must guarantee the control of the neutron physical parameters, and so on. So the number of channels which is selected usually in normal conditions we usually suggest 3 independent channel of reservation, but now in the modern project, in the modern concept of the VVI technology, we guaranteed 4 channel reservation which can operate on the 100% independently. So each safety system consists of active and passive part. What does it mean? Under the passive part of the safety system, we suggest that the system can be operated without human under the physical principles and without electricity. And the safety function will be guaranteed in any cases. But each system or each second part of the system can be operated by the human and must be controlled by the personnel of the NPP. Each safety system and each channel of the safety system must be separated, special separated, and must be protected from the different accidents, and must be protected from the human, from the personnel. And now, in our nuclear power plant, we increase the amount of the automatically procedures, which is guaranteed the safety, and operator errors can be fixed by the automatic system, which is used to protect the different actions and block operators' control actions and balanced different safety scenarios and so on. The active safety system are provided with extra source of the electricity, is the generators, which are independent from the nuclear power plant electricities, and that's guaranteed that if we shut down the nuclear reactor, we have extra source of electricity and our active system will be in order, and we can continue to operation and control our nuclear reactor. So some specific features of VVI reactor installations or power unit VVI technologies. We must guarantee the coolant inventory in the primary circuit through the main circulation pump and pressurizers in any aspects with the safety of mass and heat mass, the fuel mass and heat power. We must guarantee and control the water, the necessary amount of the water in our horizontal steam generators, which placed in the fourth reservation in the primary circuit. Must guarantee the necessary amount of the control rods under the screen and which is operated according to the gravitational forces. And this is the passive part of the CPS control and protection system. What else? The core power self-limitation properties must be guaranteed through the neutron physical properties of the VVI and according to the calculation, our nuclear reactors have a negative coefficient of reactivity. That means our nuclear reactor can move to the subcritical state by itself during the operation. And using the passive components, which is strongly important for our safety system, which is isolated and realize the restriction and tapped on the different devices. And the last, we using the inertia and run out special retention mass in main circulation pump to realize the decrease of the flow rate through the core and the loss of power. Now let's talking about some safety system. First of all, it will be the emergency core cooling system, ECCS, and as I already said, it must be divided in the active part and passive part. Like an example of reservation, look in the picture and you saw, for example, we have 4 independent channels which can guarantee the cooldown of the nuclear reactor core during any cases. And for example, first channel under repair, second channel give us a single failure. Something happened, for example, in the vessels, and the third channel is another failure, and we guarantee that the fourth channel will provide the cooldown of our nuclear reactor. That's why we do the fourth reservation in our nuclear reactors. And you can see the parameters of the hot loop and the cold loop in the table, and the emergency core cooling system must guaranteed cooldown of the nuclear reactor fuel in any cases, and even in case of the maximum design basis accidents with the rupture of the D850 is the biggest pipeline of our nuclear reactor core. Even in case of rupture, we must guarantee the cooldown. So the passive part of the ECCS, emergency core cooling system, is the system of the hydro accumulators, which is placed on the top of the containment of nuclear power plant, and due to gravitation forces, when the temperature increases or pressure under the containment increases, by gravitation forces will be open the hydro accumulators and boron acid solution start to cool down the nuclear reactor core, and the cooldown with the hydro accumulators can continue several hours until the system will be fixed and we can realize the normal operation of the nuclear power plant. So the emergency boron injection system, you know that the boron acid or boron carbide is 2 main methods for control the nuclear reactor fission reaction, and in different accidents and incidents we must guarantee that we can stop the fission process by different ways, not only the control protection system and control rods, but also we must be able to increase the concentration of boron acid in the coolant of the primary circuit. For this purpose we have the emergency boron injection system, which increase the amount of the boron in primary loop, in primary circuit, in the main loops, and the increasing of the concentration up to 14 gram per kilo of coolant, and the volume of each tank it's about 150 cubic meters, sorry. And we can realize the emergency boron injection system not only in the primary loops but also in the pressurizers too, to guarantee the heat removal from nuclear reactor core. Sorry, this one and this one, the spray system, the last one. Yeah, the last one, the spray system, which is situated under the containment of the nuclear reactor nuclear power plant, and the main purpose of this system is to prevent the spread of the radioactive substances and control of the fission process too. If something happened with the nuclear reactor vessel, and radioactive substances in the gas or aerosol form start to spread under the containment, and especially we are talking about the iodine isotopes. The spray system start to increase the concentration of the water or special solution like boron acid, which we're already talking about, or hydrazine hydrate, and use different chemical substances. We will control the concentration under the containment, and spray system it can operate without personnel, and the nozzles of this system usually basically opened due to pressure under the containment. It's based on the natural forces. The next one, co-catcher. It's a new safety system which is realized in the modern VVR project. You saw how it look like during the nuclear reactor building, and what is the main feature of this system? It must prevent the spread of radioactive substances during the hardest accidents when the melting of the nuclear reactor fuel starts. And you saw that the co-catcher must support the bottom of the reactor vessel because it's situated under the nuclear reactor, and prevent the spreading of liquid fuel, and during the hardest accidents must protect the corium from the thermomechanical impact and localize any liquid substances which can form during the accidents, and reduction the amount of the nuclides and the hydrogen releases into the containment. If we look at the main scheme of the safety system of nuclear reactor with VVR 1000, you can saw that in the center is our nuclear reactor, under its co-catcher, above the system of the hydroaccumulators and nozzles under the containment, steam generators, which is connected to the emergency co-cooling system, a lot of tanks with a boron solution and different chemical substances which is able to catch and collect the radioactive substances which can release during the accidents, but which can appear during the normal operation. One more important system is, of course, income monitoring system and excom monitoring system, which are guaranteed to get all necessary parameters during the operation of nuclear power plant. And on the map, you saw this position of different detectors, each ionization chamber, thermocouples, and so on, which are situated in the nuclear reactor core and give to the personnel all necessary information about the behavior of the nuclear power plant or nuclear reactor core. Sorry. And excom monitoring system is a system of thermocouples and ionization chambers, which usually placed in the containment and measure the temperature of the concrete and the vessel, and control the neutron flux and gamma radiation. One of the important aspects of safety is, of course, radiation protection and radiation monitoring system. In any cases around the nuclear power plant, we must guarantee the duration zone, the interest zone, where we control the parameters of the doses those are different radionuclides, and you saw in the picture the position of one of the Russian NPP and the spirit of the wind. You remember that during the main safety concept on the first level of the safety do the defense in depth, we are talking about that we must choose the position of the nuclear power plant according to the climate features. That's why we must know the wind roles, where we'll spread, and what is the direction of the wind in different periods of the year. So, and around in the NPPs, we must provide the radiation monitoring, the radiation zone monitoring of the radiation situation in not only near the power plant, but in the cities near it, and provide the radiation control of the environment, and must control the amount of the radioactive substances in the air, water, soil, and grasses, for example. So, as a result, nuclear power plants with the VVR nuclear reactor is based on the technical solution which proved their reliability and effectiveness more than 40 years operation experience, because first VVR nuclear reactor operates in the Russian Federation is about 40 years. And the development and implementation of evaluation concepts of VVR give us this is one of the base safety principles which we realize on different units and continue improved and guaranteed the efficiency of such installation. And to the new project of the VVR, it's one of the branch of development of our state corporation and nuclear industry in common. And you see the current project, it's IS 106, VVR TOY, VVR 600, VVR 1400, and so on. And even if we are on the supercritical conditions of the coolant, it's installations which will be based on the balance of the active and passive safety system and optimizing of different NPP design and VVR design needs and get any modern requirements of the Russian regulation and the international regulation and guaranteed the safety in any cases. Thank you for your attention. That's all from my lecture and my presentation, and I'll be glad to answer your questions.
Thank you, Mikhail, for the interesting presentation. Now it's open for questions. Please ask your questions. So no questions. Let me then ask you a question. Yeah. Okay, you presented in your presentation actually the new generation of VVER nuclear reactors, which is typical Russian design. This design is considered to be generation 3+. My question is, if you remember in Kozloduy, our units contain nuclear reactors of generation 3, not 3+. We know that generation 3+ has surrounded by 2 containments, while reactors in Kozloduy are surrounded by only 1. Do you think that reactors in Kozloduy are less safe because of this?
I think the 2 containment is our modern feature, but we operate now a lot of nuclear reactors of their type which have 1 containment too, and I think that 1 containment nuclear reactor will can guarantee the necessary level of the safety, and they can operate during different conditions, you know, that the hurricanes, plane crash, and so on. And even 1 containment VVR calculated according this accident and incidents, and I think the safety system which is placed under the containment can guarantee necessary the safety and protection from different sources.
Okay, okay, thank you for the answer. Please, questions. Somebody is typing. Okay, we have a question now. How large is the area around NPP in which we must do radiation dose monitoring? This is a question from Alexander Georgiev.
Yeah, actually, it depends from the regulation of your country, but for example, for Russian Federation, the radius of such zone, if we calculate from the center of the NPP, it's about 30 kilometers. Where we control the balance of the radioactive substances. It's like an observation zone around the NPP.
Thank you for the answer. There's another question from Ivan Teklev. In VVR 1000, if we reach a point where the boric acid is injected in the coolant, what is the expected reduction in the fuel campaign?
You know, if we already provide the injection of the boron acid in nuclear reactor, we stop the calculation of the fuel campaign until we go back to the normal operation. And if the boron concentration increased in the nuclear reactor core, we stop the fission process, and the company of the nuclear reactor will be in paused. Because the fission process stopped and the amount of the uranium-5 and plutonium-9 in the fuel will be the same before the injection. And we, after the come back to the normal operation, we can continue operating on the same fuel.
Yeah, I think yes, thank you very much. I think the question exactly mentioned was dedicated to if the boric acid can shut down the reactor, which you answered perfectly. Thank you very much. Other questions? So, no more questions. Let's thank Mikhail.
Great. Thank you very much.
Thank you very much for this interesting presentation. And I would like to announce 5 minutes break for coffee. Please be back after 5 minutes. Now is 12:23. After 5 minutes, we will be back. Hello, everyone, back. Everybody is here? Okay. Okay. Let's continue our lecture day. I would like to welcome our next speaker, Tadeusz Kashayar, who is assistant professor in St. Petersburg Polytechnic State University. He will present lecture on the topic nuclear desalination. Okay. Please, microphone is yours.
Hello. Can you hear me?
Yeah, we can hear you.
Okay, very good. Thank you very much for your explanation. Again, I'm gonna introduce myself. My name is Khashayar, and I'm the assistant professor at Polytechnic University of St. Petersburg. And I'm so delighted that today I have the opportunity of being with you and explaining our work. So let's start our work very fast. The topic is about the nuclear desalination. Today, generally, I'm gonna give you general information about the nuclear desalination. First, I'm gonna talk with you about the general aspects of desalination. What does it mean? Why it is important for our board, I mean the desalination. And then we are going to talk about the main methods or technologies of desalination that currently they are used. And after that, we'll talk about the economic aspects of the nuclear desalination. So let's start. Today in this period, we will talk about 4 WH questions, and these are 4 essential WH questions about the nuclear desalination. First, why desalination? It's very important to understand what is the importance of desalination for us. And second, which methods? Also, it's very important to select the best and the most optimum method for desalination. And how to combine nuclear power plant to desalination plant, because in the future you understand that you have many different energy sources for driving the desalination plants. But we are going to select nuclear power plants. So we should understand and we should define why we are going to use nuclear power plant and nuclear energy for desalination plant. And finally, the most important thing for any technology and for any equipment is the economic evaluation. So we'll talk about the cost of the nuclear desalination. Probably you will think with yourself that right now we have many oceans and seas in the world, and we have enough water in the world. So why we need to desalination process? But here is a very important point. Of course, we have enough water in the world, but they are not usable. It means that almost 97.5% of total water resources in the world they are not usable. They are the water of sea and ocean, and they are salty water, so we cannot use them as a fresh water and for drinking. Many countries, many regions in the world right now, they are facing with the water shortage, like for example the Middle East countries, the countries that are located at Middle East, for example, like Iraq, like Iran, like Saudi Arabia, like Emirates. They are all located at Middle East, and they are facing with a very serious problem of water shortage. Or for example, in some parts of the United States or the countries that are located around the Mediterranean region. So it's a very big problem to provide enough water for people, not only for domestic application, even for industrial application. We have to provide enough fresh water to be used. As you can see here, almost 2.5% of all the water in the world is fresh water. But again, here we have a very important point. We cannot use all this 2.5% of water, because from this water, 30% is groundwater and 70% is ice caps, and we cannot use them. They are practically they are not usable. So just 0.3% of all the water in the world, they are surface water, and they can be used for domestic and industrial application. So we should think about it, and we should find a solution for solving this problem. Again, in this picture, you can see the main regions in the world that they are facing with water shortage. And you can see, for example, the countries that are highlighted by red color, they are located at the extremely high stress. And you can see the countries here, like Saudi Arabia, or north of Africa, or south of America, or some part of India, or the other countries at the Middle East, they are facing with the water shortage. Currently, the best and the most optimum solution for water shortage is seawater desalination. And many countries in the world, they are using this technology, this method. It means we can produce fresh water from seawater or ocean water, and converting the saline water from sea to fresh water. More than 150 countries in the world, they are trying to solve the problem through the seawater desalination technology. And globally, at the end of 2050, around 80 million cubic meters per day of potable water or of fresh water is being produced daily. So you see that it's a very huge amount of water that is produced by different technologies of desalination. So let's take a look at the main technologies of seawater desalination. Essentially, we have three different types for seawater desalination. First, evaporation, condensation, second, filtration, and finally, crystallization. Evaporation and condensation also can be classified into two parts, thermal processes and mechanical processes. Thermal processes also has four different groups, like solar steel distillation, that is use solar energy for producing fresh water, or humidification, dehumidification, or with the abbreviation of HDH, a multi-effect distillation, MED, and multi-stage flash desalination, MSF. The other technologies of mechanical process, like for example TVC, thermal vapor compression, or mechanical vapor compression. For filtration, also we have several different types: membrane distillation, MD, or forward osmosis, or reverse osmosis. These are the most important technologies of seawater desalination through the filtration method. And finally, the crystallization. We have two different methods: freezing and hydration. But we want to talk about the commercial technology. It means that we want to produce thousands of cubic meters fresh water per day. So we should select the best technology, and we should select the technology that by which we can produce a huge amount of water per day. Among all these technologies, we select multi-effect distillation, or MED, and multi-stage flash desalination, or MSF, and also reverse osmosis, or RO. These are the main technologies for producing fresh water, and in large scale. It's very important to consider this one. In large scale, we are going to produce fresh water. Okay, so let's take a look to all these technologies, 3D technology. Before that, we want to talk about the essential of seawater desalination plant. For any seawater desalination plant, we have two inputs and two outputs. So what are the inputs? You can see here first we should have feed water, feed water can be supplied by water from sea, ocean, or even brackish water. And about the energy, second input parameter for desalination plant is energy. So we should supply the required energy for desalination plant. We have many different sources for supplying energy, like for example, a thermal power plant, nuclear power plant, solar power plant, wind, and many different types of energy sources. So this is the second input. And what about the output? We have two main outputs. First, product water, or the fresh water that is produced, and is it drinkable and we can use it. And the second one is the rejected brine, or it means that the water that couldn't be treated. So these are two outputs. And the core of the technology is a separation unit. In the separation unit, we can have thermal or membrane technology, as I explained you. Thermal like MSF and MED, and membrane like RO technology. Here we can see the share of each desalination process in global installed capacity. You can see that RO, as I explained you, is as you can see here, almost has a 60% contribution in global desalination market in the world, 60%, and after that we have MSF, 26% also almost, and after that MED with 8%. So as you can see in the world, the interest of using RO is more than MSF, and MSF is more than MED. And what about the world desalination plants per geographical area? You can see that 53% of all the desalination plants are located at Middle East. So it means that these countries at Middle East, they are facing with a very serious problem with water shortage. So let's take a look very briefly. I'm gonna explain you, because of course we don't have enough time to talk about the details of these equipment. So just very fast, we will take a look to them. Multi-stage flash, or MSF distillation plant. The structure is very simple. The feed water from the sea is pumped from here, and then from different effects, it is passing through different effects. And at this point, at the first effect, or at the first chamber, the steam from boiler comes to this state. This steam is almost it is like energy for driving the desalination plant. And by transferring heat between the water in this pipe and also the steam in the first chamber, some part of the water in the tube or in the pipe can be converted to steam, and the produced steam goes to the next step. And here, by transferring heat between the produced steam and the cold surface of tube, a part of this steam converted to fresh water, and we can collect this fresh water. So next step again like that, and so on. This is the general scheme of MSF. You can see some real scheme and real sites or plans of MSF in different countries like UAE and Saudi Arabia. This is like the second one is the biggest desalination plant in the world. The next one is multiple effect distillation, or MED. Again, the structure and the technology is not very complex. Here we have driver steam. That means the steam that can supply the required energy for the desalination plant. The steam comes to the first step. Here is the first step or first effect, it's called. And feed water in the green pipe is sprayed on the hot pipes. So by transferring heat between pipes, between the hot surface of pipe and also sprayed water, a part of this sprayed water can be converted to steam, and the produced steam goes to the next step, and again in the next step by transferring heat between steam and water, a part of this steam is converted to fresh water, and so on. This is also the general scheme of the MED plant. And finally, RO desalination process. In this process, or in this technology, the water with let's say with high level of salt is pumped through a membrane, a kind of membrane here, and the salinity of water decreases after passing through the membrane. And at the right side, we have fresh water. So it is a kind of filter. It's a kind of filtration method, and we can use it for producing water. Here you can see a general scheme of typical, let's say, typical RO plant. These are the main membrane modules. In each membrane, we have almost 4 to 7 filter of RO desalination plant. What about hybrid desalination plant? Currently, many governments and many researchers, they are interested to work with hybrid desalination plant. It means that we use a thermal desalination plant like MED or MSF plus RO desalination plant. This technology, I mean hybrid desalination plant, has many advantages in comparison to standalone desalination plant. For example, the intake water from a sea decreases. You know that providing the infrastructure for intaking water from sea is very expensive, even for nuclear power plant, even for thermal power plant, even for desalination plants. So by using hybrid desalination plant, we can decrease the amount of the volume of water that should be extracted from sea, and also we can improve the quality of produced water. The quality of produced water is very important, and it is denoted by TDS, total dissolved solid, and the unit for measuring the TDS is ppm. So, for example, the drinking water, the TDS of drinking water is almost 400 to 600 for domestic application. Using thermal desalination plant, we can produce very high quality water, and using RO desalination plant, we can produce not very high quality water. So by combining these two water, we can produce a very good and usable water for drinking. And of course, we have many more, a lot of advantages, but let's finish it here about the hybrid desalination, because we don't have enough time to talk about all the advantages. Generally, it's a very good option for producing fresh water. So the most important thing here is supplying the required energy for nuclear desalination plant. As I told you, we should supply hot steam for thermal desalination plant, and also we should use a very powerful pump for supplying the energy of RO desalination plant. Because if you want to put pressure on water to pass through the filter, you should use a very powerful pump. Of course, for driving this system, we need energy. But which type of energy we can use? Fossil fuel? No, we cannot use that. Of course, we can use it, but it's not logical because of many disadvantages of fossil fuels. We don't want to use them. If you want to get, or if you want to achieve the net zero emission goals, we cannot use fossil fuel, and also for producing carbon dioxide. And the other reasons we don't want, of course we don't want to use fossil fuel. What about solar energy? Is it possible? Of course, solar energy also is a very good source of energy, but again, here we have a very big problem. That is, if you want to produce many thousand cubic meters fresh water per day, then solar energy is not enough for our work. We need a very big land. It's even sometimes it's more expensive than, for example, fossil fuel. And it's not logical to use solar energy for large scale desalination plant. And finally, we want to talk about the nuclear energy for driving the desalination plant. Of course, it is possible to use the produced heat from the core of the reactor for supplying the seawater desalination. In the literature, we have many, not many, it's not true to say many, but we have several examples of using nuclear energy for driving the desalination plant. For example, in Kazakhstan, we had an LNFR reactor, or in Russia, Argentina, right now they are working on that, or some kind of PWR in Korea. It is used for supplying the required energy of desalination plant. What is the nuclear desalination? Let's talk about the terminology of nuclear desalination. Nuclear desalination is the process of producing fresh water using an on-site nuclear reactor. This is the general definition of nuclear desalination. Of course, according to the IAEA terminology, we can give another definition. It can be explained like that. Nuclear desalination is introduced as the mechanical and thermal process applied to seawater, which leads to producing fresh water. In the internet, we can find many different technical documents of nuclear desalination through the site of IAEA. This is free of charge, and you can download them and read them. You can find many useful information about them. And the efficiency and cost analysis and safety of nuclear desalination are the main objective of nuclear desalination analysis, especially the safety of nuclear desalination. It's very important, and right now I cannot find many studies about the safety analysis of nuclear desalination, but it's a very good work for future studies. And in theory, all types of nuclear reactors can be used for supplying the required energy for desalination plant, because the most important thing for driving the desalination plant is heat and electricity. These two forms of energy. So electricity is the essential product of all the nuclear power plant in the world. So easily we can use electricity from nuclear power plant. And the second one, heat. Of course, we know that all the nuclear power plants can produce heat. And at the second cycle of nuclear power plant, we can install a kind of plant to extract steam from the turbine building and use this steam for driving the desalination plant. Here you can see a table of different experiences of nuclear desalination in the world. The most important one is LMFR in Kazakhstan, and it was under operated many years ago, and 1999, after 26 years, reactor years, it was shut down. And it is the most important example of nuclear desalination in the world. Right now, also we have many different nuclear desalination plants that they are underdeveloped, or they are operating, like for example in Japan, as you can see, MED, MSFR, or the other example, you can see India, Canada, Pakistan, Japan, China, Russia. They are all developing their technology in nuclear desalination. As I told you, the most important example of nuclear desalination is in Aktau in Kazakhstan, and it was shut down in 1999. The type of the reactor is a sodium cooled fast reactor BN350, and this system was used to produce not only electricity but also heat for this desalination plant and also heat for district heating system. And another thermal power plant was connected to this system for enhancing the produced energy. The exhaust steam was 0.6 megapascal from the back pressure turbine, and it was used for for feeding the first stage of the MED plant. So it was an MED plant that was connected to the desalination, to the nuclear power plant. Here you can see a picture of that site. It's very old picture, and the capacity of this nuclear desalination plant was 80,000 cubic meter per day of fresh water for industrial use and drinking, both domestic and industrial. Of course, we can connect nuclear power plant to desalination plant in different ways. But here I want to share with you 4 important schemes, and they are very easy for understanding. The first option is simple hybrid scheme. The next one is integrated hybrid scheme. Third option is it's not correct. Third option is use of cooling water of nuclear power plant condenser as feed water of desalination plant, and finally using MSF brine as the feed water of MED. Let's take a look to all these schemes. The first one, separate desalination plant, MED, MSF, and RO. Okay, here you can see a general scheme of a nuclear power plant. This is the, let's say, steam generator, or if we have a kind of SMR, we can say the SMR reactor, SMR modular reactor, then we can say that it is the reactor building, and high pressure turbine, low pressure turbine, and generator. Okay, these are preheaters and condenser. So the scheme is very easy. We can extract electricity from generator and give it to RO system. In this part, we have RO system. And this is the MED or MSF system. Also, we can extract the steam from low pressure turbine or high pressure turbine and give it to the intermediate loop. This is an intermediate loop between a thermal desalination plant and nuclear power plant. It's very important because of increasing the safety aspects of the site. To avoid any emission of radioactive material through any accident in the reactor, we have to use this intermediate loop. And this is very, very simple scheme. The next scheme is that we can extract, we can produce water by RO desalination plant, and the rejected water, the brine water, can be given to the MED plant as the feed water. So in this scheme, the cost of intake water infrastructure decreases. And the next one is a very optimum method. In this scheme, we can use the rejected water of condenser of NPP or nuclear power plant as the feed water of desalination plants. In this scheme, totally we remove the cost of intake water infrastructure. And the cost in this scheme is very, very low, and also it's very easy to implement in the site. Finally, we want to talk about the economic result. It's a very, very general economic evaluation for a kind of plant with the capacity of 150,000 cubic meters per day for RO, MED, and MSF technologies. The cost of water is formed from mainly 3 factors or components. First one is the capital cost, total capital cost of the plant, and then operating and maintenance costs, and the total energy cost. Okay, so we have 3 different components for evaluating the cost of the technologies. For RO, you can see that the capital cost of RO is less than MED and less than for MSF, of course, because the equipment of MSF, they are more expensive than MED and RO. But in the cost of the energy, you can see that the thermal energy cost for RO is 0, because as I told you, RO just use electricity, not heat. But electricity cost of RO is more than MED and MSF, because we should use a very very powerful pump for running the desalination plant. And also MED and MSF, you can see this is the cost of the energy. For MSF, the cost of the energy is very high because we have to use a huge amount of heat for driving the MSF. So as you can see, it's very costly. And finally, the total, operating and total operating and maintenance cost. Again, as you can see, the cost of RO is more than MED and MSF. Why? Because in RO plant, we have filters, and each year and each 5 years, 4 years, we have to check all of them. We have to replace some new filters with that one. So the operating and maintenance cost of RO is higher than MED and MSF. And finally, you can see the total cost of water, the specific total cost of water for RO is, like, for example, 0.8, for MED 1.2, and for MSF is $1.8 per cubic meter. So as a conclusion, you can say that MSF technology is very expensive in comparison to RO and MED if we use the nuclear energy as the energy driver of the system. Okay, thank you very much. I tried to explain all the important things to give you a general view. Of course, nuclear desalination is very widespread, and we cannot talk about all the details in 25-30 minutes. But I hope that it was useful for you. If you have any question, I'm ready to answer to you. And thank you very much for your attention, of course.
Thank you. Thank you very much for this very interesting presentation. Indeed, this is very new field for us. So I hope that was interesting for everyone. Please ask your questions. Okay, question comes from Adrian. Adrian wrote this question: in a hybrid desalination plant, does the order in which different methods are applied matter? I think the question means the order of the methods are applied to the plant. Hybrid desalination.
Yes, let me explain about it. In hybrid desalination plant, we use thermal and filtration. Thermal and RO plants together means MED, MSF, and the next technology is RO technology. But it's very important to know the capacity of each one of them. For example, for MSF and MED, it should be almost 30 to 40% of all the total produced water. And for RO, it should be 60%. Why we select these orders or these numbers? Because we want to produce a high quality water, and according to the calculations, we can obtain that by combination of 30% of thermal desalination plant and 70% of RO desalination plant. We can produce the best water for drinking and the other application. As I understood, I explained about this question. But if you have any more questions, please tell me.
Okay, thank you. Thank you very much. Other questions? Maybe I can ask one question until somebody decided to ask. My question is, you talk about desalination of seawater, and the process of this desalination supposed to meet requirements of the fresh water for the general population. When we apply nuclear power plant desalination, will be water suitable for drinking, or it will be just for technical purposes?
Okay, it depends on the technology and the capacity of the plant. For example, in some countries they need fresh water, so they have to produce more than 200,000 cubic meter per day for drinking water of regions, of cities. But sometimes you want just to supply the required water for site. For example, the produced water from MED and MSF is very, very pure, so we can use this water for water of first cycle of nuclear power plant, and it can be used in the site. But sometimes no, you want to use this water, this produced water, for city. So it depends on the strategy of the site, strategy of the government and the region. you can use both of them. If you want to use just in the site, it won't be more than 5,000 cubic meter per day is enough for just application of site and make a water for first cycle and something like that. But if you want to produce water for cities, then it should be at least more than 100,000 cubic meter per day. Because it should, from the economy point of view, it should be beneficial for us to make a very, very large scale desalination plant, and so we should increase the capacity of the site.
So how I understand that depends on the customer. If customer orders to provide pure water for drinking, it will be done. If required for technical uses, it will be done for technical uses.
Yes, exactly. But we should consider the balance of electricity production and water production, because as we increase the capacity of nuclear desalination plant, we should decrease the capacity of electricity production, because the useful heat instead of producing electricity is used to produce fresh water. So, for example, the efficiency, the electrical efficiency of the system from 33, for example, typical 33% is dropped to, for example, 30, 29, 28. But the thermal efficiency of the cogeneration plant, because it's a kind of cogeneration plant, at the same time we produce heat and we produce electricity. The efficiency of cogeneration plant increases. So we should make a balance between them. We should consider the demand electricity of the nets of the grid. We should consider that, and also we should consider the required water, and then we can make a balanced water and produce water.
Okay, thank you very much. So I'm very happy to hear that no technological limitation on this. It just depends on the customers. So thank you very much for the interesting presentation. Let's continue further with the presentations. The next presentation will be maintenance and cooperations with customers. It will be presented by Stepan Ziryanov, who is Deputy Director of the Center for Radiation and Sterilization of Uralian Federal University. So please, your microphone is yours.
Hello, do you hear me? Everything is okay?
Yes, I can hear you.
Okay, nice. So I'll start. I'll tell you about another application of ionizing radiation. I'll give you a short review on e-beam technology. I'll tell you a few words about our accelerator. I'll show you what problems we had. It's very interesting and important because people like to tell how everything is perfect, but solving problems is the best experience. You'll see what areas you need to pay attention for. And at the end, I will show you how we work with new types of products to ensure the quality. These characteristics are not for e-beam with converter to X-ray. It's mostly for situation when you use electron beam for irradiation. Energy is up to 10 MeV, mega electron volts. At higher energy, you will have activation and induced activity in your products. Power ranges. The limit is the heating you will have after the products pass under the beam. You need to have a high-speed conveyor to fully use the power. Or you can use tubes with products like grains or wastewater. At low limit, about 1 kilowatt, you will need too much time for irradiation. Penetration of ionizing radiation is high enough, but you have some difference in dose distribution comparing to gamma radiation, and I'll show you later the difference. Such facilities can work almost the whole year around. This high dose rate is right under the beam. It is used only for material studies, radiation destruction of material defect generations in solids. So, To start using electron beam, you need first of all an accelerator. Here on the picture. You need electricity, then using pulse modulator you convert electricity to electrical impulses with amplitude of a few kilovolts and about 10 microseconds length. This pulse goes to pulse transformer to be converted to even more higher amplitude, and the klystron forms the wave which bring the power to accelerator tube. In accelerator tube you have an electron source. The electromagnetic wave takes these electrons and brings them down to your products. You have focusing magnets and scanning magnets. Focusing magnets to have electron beam more concentrated, and scanning magnets to cover the whole surface of your product. At the bottom of the picture you see the conveyor system with boxes. Better if you have it with two different parts with different speeds, to have no spaces between boxes when they go under the beam. Next slide is and of course cooling system and the operator's computer. So you can see what is the possibility of electron beam. For example, sprout inhibition for beta storage, insects disinfection to be sure you'll keep your products for a long time, parasite control for some food like fish snacks, for example. Here you see also the doses you need for different effects. Delay of ripening, if you want to bring your mango to another continent. Fungi and bacteria control, if you need to control their growth or their type. Sterilization, it's what we do. Polymerization at higher dose, if you want to create some polymer using monomers. Grafting monomers, to add some another monomers to polymer chains. Cross-linking polymers, for example, to get them thermoshrinkable properties. Degradation, even more higher doses. If you decided to go back to these studies and to destroy everything you created earlier. Another application is coloring gemstones to sell them at higher prices. You can generate defects in solids starting from 10 kilogray and higher. So it's our accelerator before upgrade. It's a pulse transformer, klystron, waveguide, vacuum tube, pulse transformer for electron source, and you see cooling system. Next slide, it's our accelerator after upgrade. We changed old French klystron, red one on this slide, to new Russian klystron. It's a spare part and needs to be changed periodically. Main computer, video control unit, dosimetry system, and blocking system, and also oscilloscope to control waveform. So, advantages of electron beam technology. It is well-known technology, about 100 years. Simplicity of construction. You need just a tube and a klystron and a few engineers. High parameters stability, about 3-5% stability in beam current. High beam power. High beam power means high yield of products. Narrow energy spread. You have your beam only in the place you know well, and you put products here. All other places are free from irradiation. And wide range of power adjustment. You can change the power on demand. Disadvantages of technology. It's a limited lifetime of klystron or magnetron. It depends on design. You need to buy klystron or magnetron periodically from 1000 to 5000 hours. High electric energy demands. If you have 10 kilowatt in beam power, you need about 70 kilowatt for your facility. Poor accelerator tuning. Limited energy variation. You cannot change electron energy as you like. It often very limited range. Difficult in spare parts availability, also the problem, because often you have some parts very new and not in serial production, some parts old and out of stocks, and another parts with very high price to buy. And high demands on technical staff qualification. Keep your engineers. You need them to make all this work. So we start with our accelerator experience. We will talk about power modulator, about high humidity in high dose rate field, about start-stop system for e-beam and conveyor, about human access blocking system, and irradiation chamber video control unit. You will see the example of problem and example of solving this problem. Typically, you have no problems if you run the accelerator for 1 or 2 hours per day. When you start to work, for example, 6 hours, you will have some problems with its stability. For 12 working hours, it will be the next set of problems. Example of problem: a limited working temperature range of electronic components like condensers, resistors, microcircuits. Solve, edit additional air ventilation for modulator room, edit local fan for better cooling and temperature stability, new demagnetizing scheme for pulse transformer. Some pictures to show upgrades. Another problem, high requirements for power quality and stability. Solve, edit oscilloscope control of phase and frequency characteristics. And also edit UPS power supply unit for klystron cooling system. It's most critical because very high temperature and high power and very small water volume inside the klystron, and the water can boil if you stop the circulation of water for cooling of klystron. In this situation, the klystron can be broken. Another problem, humid air irradiation leads to nitrogen or nitrogenous acid generation inside irradiation chamber. Acids vapor destruct accelerator parts and electronic components. Solving of this problem, most critical electronic components are protected with high purity silicon lubricant to keep electric connection. Another problem, software and microcontroller faults leading to irradiation of products with stopped conveyor, risk of fire. So you have a very high power, about 10 kilowatt, you send it to the box, you irradiate, and if you stop moving the box, all this power is concentrated in one box. In a few minutes, you will have a fire in this place. We developed a low-level electrical blocking system for prevention of such cases. There is a possibility to deactivate it for accelerator maintenance and tuning. Another problem connected with software and microcontroller faults is may lead to human access to irradiation room. We developed a low-level electrical blocking system for prevention of human access during irradiation. The operator needs to go through the perimeter of limited access area before starting irradiation to be sure there are no humans here. We have a few checkpoints with button to press if everything is okay. So every corner is checked and we start irradiation. Look like on this slide. Another problem, it's a camera optics darkening and CCD sensor degradation in high dose rate fields due to radiation defects generation. So camera unit is placed out of E-beam direct view. A polished stainless steel mirror is used to see the image behind the corner of irradiation room. So, going closer to our everyday work and to irradiation. You know this idea about good, fast and cheap. Select any tool you prefer. In our area of work, quality is regulated by law. You cannot do your work bad because you will be closed. If you say you do sterilization, you must do it. To tell about speed, you need to do it as fast as possible to irradiate more products. We can modify techniques, we can optimize people job and use working time more effectively. The way for our customer is to find best packaging, not too heavy, not too light, and so on. I'll show you later. We need the products to be irradiated at any place in conveyor, so we tune our beam to provide the heterogeneity about 5%. About dose distribution. Here you see the difference between depth penetration of gamma radiation and electron beam radiation. For E-beam, for gamma and X-ray, you have exponential decline. For E-beam, it's a curve like this. It depends on Z number and electron energy. It's a dose distribution for one-side irradiation. For two-side irradiation, you need to add another one curve like this, and the dose will be sum of these two curves. What we do to help our customers, we explain how it works, how dose distribution depends on density of products and so on, how we can correct the packaging of materials and products, and check dose distribution for each product they have. Here we show typical products from our main customer, Dramitech. It's a disposable medical goods and typical folds there. It's free spaces. It's intercrossing of packaging ends. We will have lower dose at these points. And if the dosimeter for control of radiation is situated at the other place, we will think that everything is fine, but in fact the dose is lower because the density in this region is higher. The same situation with free place. If we put the dosimeter here, we will see that the dose have the dose is higher or lower than it must be for this box. And another situation that packaging can move inside the box when you turn it to the other side. So for both sides radiation, it must be fixed inside the box. And this situation usually not allowed for packaging. Mix packaging is allowed only for high number of individual packs. If, for example, if you have 1 or 200 of individual packs, it can be put in the box like on the picture. Another product we have, it's a polyethylene tubes. We radiate these tubes to give them thermoshrinkable properties. We use four-side radiation for these tubes. According to our measurement, we have dose distribution in dose range about 120-150 kilogray, with maximum situated from top, bottom, left and right side. Sometimes the maximum dose is situated in other regions, and it depends on tube diameter and the thickness. This situation we have according to dose distribution I showed earlier. So first of all, we check for such a product the dose we need to be sure that we can enlarge tubes after irradiation. We measured how much time we need to rotate them, 2 or 4 or maybe 6 times. We gave recommendation to do 10 centimeter layer for this packaging after first measurements. It was 8 millimeter tube with 1 millimeter wall thickness. After we got a new batch of products, we could not even carry them because the tubes was 6 millimeter diameters and wall thickness was 2 millimeter. The weight of this tube was more than 2 times higher, and we could not irradiate them. We started measurements again, and finally we recommended the effective thickness of about 16 millimeters of polyethylene, which is linked to electron stopping range in material. So if you have 8 millimeters tube with 1 millimeter wall, it's about 8 layers. And if you have 6 millimeter tubes with 2 millimeter wall, it's only 4 layers. So we always try to explain to our customer how to do the irradiation more effectively. Sometimes we have 2 or 3 times lower products volume after our help, but our customers come again to us for irradiation or sterilization. So thank you for your attention, and here you see our physico-technical faculty where our facility is situated. Thank you.
Thank you very much, Stepan, for this nice presentation. It was really interesting. It's for many of you this new area. I think a lot of people, a lot of students here didn't know that food and materials can be sterilized by irradiation. So please ask your questions.
In Bulgaria, you have such facility.
Yes, I know. We have students from this facility here in our
Okay.
university. Please, questions? So not questions yet, but let me ask you one question just until people still think about their questions. Let's imagine like situation. I'm exporter who export bananas, as example, to Bulgaria. So I would like you to sterilize these bananas before to come to the Bulgarian market. So there are two possible options. The first option, you sterilize, and after that I come to you and I said, okay, you cooked my bananas because you applied too much heat on them. So, and the second option is, okay, I come to you after sterilization, and my final customers, they complain that they got amoebas sickness. So you didn't sterilize properly my product. How you avoid such cases? Do you take some sample, irradiate it until it is cooked or broken, or you just calculate relying on the people, the words, or you just open, measured, weight everything to properly to irradiate it? Can you provide quality assurance of your work? How you do this?
Yes, of course. For sterilization, for example, it controlled by regulatory body. We have all certificates that the goods after our sterilization are completely sterile. And if we talk about food irradiation, if you want to cook bananas, it is possible because we have 10 kilowatt power. So you need to stop for maybe a few minutes and you will have them cooked. After irradiation at 10 kilograde, they will be at a temperature about 30 degrees, no more. And if you talk about insects, lower dose will be enough for about 1 or 2 kilograde. So the temperature will not change. And if you would like to keep them after sterilization or after radiation, you just need to pack them well. So after irradiation, typically the products can be kept for 5 years in their individual packs. So pack it well, give the dose you want, and you will have the effect you need.
Oh, okay. This is additional, I would say, extras in your results of your work, so you can extend the time of the usage that product can be used. If you talk about food products.
Yes,
right?
of course.
Okay. Thank you for presentation.
Thank you.
I see somebody is trying to typing. Okay. Vasil is typing. Vasil, can you ask your question? Okay, he's already. About the bananas, can the beam affect the potassium inside?
And what potassium? About
Potassium калий.
Да. It's like a natural radiation. If we talk about potassium, we cannot change it, not to add, not to have less potassium inside. So With energy of 10 MeV, we don't have activation of material. And I see another question about how people, mass audience, accept our services.
Yeah,
so,
that I missed. Sorry for this. I just wanted to ask again. Sorry.
So usually people are afraid of irradiation. It's a problem, of course, because when they hear about irradiation, about sterilization with electron beam, they say, oh, it's radioactive. No, it's not radioactive because the energy of electrons is limited at 10 MeV. We have no activation of material. We stop beam and we have no irradiation inside the irradiation chamber, inside products, inside boxes. So it's completely safe.
Okay, okay. Thank you very much. It's very important to know that irradiations has such a wide application. At the same time, it's provide enhancing safety of the food and the products that we use every day, daily. So thank you very much for presentations. No more questions, I think. So let's have 5 minutes, maybe more, maybe 10 minutes break now. So please go back after 10 minutes. So 1:41, 40 minutes past 1, 41 minutes past 1. I will write right here.
Okay.
Moscow. Alexander, please, you can start your presentation.
Yes. Good afternoon, all colleagues, all participants. First of all, Plamen, what about quality? All is okay or not? Voice, video?
Yes, everything is perfect.
Great. Please, if will be some problems with internet, please let me know. In this case, I can change my computer. But
okay, okay. Okay, I will type on the chat if something is wrong. So
yeah,
you can...
great. Yeah. So, first of all, good news that really this presentation is the last one for today. I think that our participants really a little bit tired to get so huge volume of information. So I'll try to be concise and to explain my ideas in brief form for our participants. And you see this title on the screen. So, about myself, really, yes, like Plamen said, I'm deputy head of a nuclear physics and engineering department in Obnitz site of National Research Nuclear University MFE, and I'm involved in international activity of our university. So, briefly about MFE University, about my university, because MFE really one of the leading technical university in Russia, and as well as one of the leading nuclear university. I guess not only in Russia, but in the world, because nuclear is not so big area, and actually in the world there are not so many universities specialized in this area, especially. Nevertheless, MFE, of course, nuclear is one of major direction maybe, but as well as my direction is Institute of Nuclear Physics and Engineering, but there are several others, like Institute for Laser and Plasma Technologies, like Institute of Cyber Intelligence Systems, Institute of Engineering Physics for Biomedicine, it's like nuclear medicine but modified, Institute for Physico-Technical Intelligence Systems, and Nano-Engineering in Electronics, Electronics and Photonics. And of course, there are a lot of branches all around Russia. There is one international branch in Uzbekistan, in Asia. So, and there is headquarters, there is campus in Moscow, and campuses all around Russia. MFE, like university, is deeply involved in international activity, of course, especially in the field of nuclear education. On this slide, you can see geography of our students for preparatory faculty, for master's, bachelor's programs, and PhD. So really, you can see it's a lot of countries. First of all, it's all Asia, Eastern Europe, and Latin America, Africa, and so on. Actually, all international students are divided between Moscow side of our university and Obninsk. Obninsk, it's a really small town, not city, maybe 100,000 people in 100 kilometers away from Moscow. So it's nearest branch from Moscow. And we have a lot of international students there. So about programs. When we're talking about nuclear education, from one side in the Russian Federation, it looks like rather simple, because there are only two main directions of bachelor and master programs. First one is nuclear physics and technologies, and second one is nuclear power engineering and thermal physics. And inside of these directions, there are really a list of programs, and you can see names of these programs on this slide. Programs really reflect major of this specialty. So nuclear physics and technologies, first of all, are oriented for countries with centers of nuclear science and technology, planned to construction, and nuclear power engineering, first of all, is intended for countries with nuclear power plants. So on the previous slide, it was bachelor programs, masters and graduate programs are presented on these slides. Idea is the same, and I'd like to add that in this slide, actually, I guess, dots, red and blue dots, really indicate Moscow or Obninsk site. Moreover, there is one more specific. Nowadays, our university provide courses both in English medium and Russian medium. If you want to study in Russian, of course, as usual, you should to go through so-called preparatory faculty during 1 year, just to learn Russian language. If you want to study in English, of course, there are no preliminary stages. You can start from the 1st September on the first course. All our international students live in dormitories, in fully equipped dormitories in Moscow and Obninsk. And on this slide, there are different informations about auxiliaries, about conditions, and so on. And one more international, very interesting activity for not only our students, but for students from international universities abroad. It's summer schools. Every year we provide several summer schools, as usual in English, for students actually all around the world. And moreover, during pandemic stage, actually second year of pandemic, from one side, of course, it's very hard to taught students in distant form, but from other side, it's big advantage because we can attract a lot of people without need to visit Russia personally, because it's, you know, it's economy for flights, for living expenses, and so on. And my presentation, I'd like to say really about describing place of nuclear in the energy market, and some thoughts about economy, about money, and about ecology. First of all, about environmental issues. So first part, really, it's a general part about nowadays situation in the world and place of Russia, like country in this area. On this slide, you can find shares of different fuels of primary energy in the world. And of course, in this case, you see source 1 year ago. These numbers, of course, are subject to change year by year. But in general, nowadays in the world, nuclear has approximately 4 point something, below 5% of share. And in this case, we talk about primary energy. So number one, you see, it's oil and coal. Moreover, it's not electricity production, because for electricity production, number one is coal, actually. And renewables, small enough, but by the way, it's bigger than nuclear nowadays. But when we talking about different alternatives, different possible sources of energy, of course, I think it's a bad idea to discuss the world as a whole. Of course, it's better to say about different countries, because on this slide, for example, you see a map of world power generation, and size of these circles depend on volume of power generation in 1,000 gigawatt hours according to this scale, and color stands for different source like thermal, nuclear, and so on. So of course, first of all, you see, I guess majority of countries, the red area is the biggest in the world. Nowadays, the coal and gas, first of all, are number one if we talk about fossil fuels. Nuclear in some countries, like United States, like in Russia, it's some maybe significant sector. Like France, maybe now the only example, because France is number one in share of nuclear, more than 70%. But some countries, for example, Latin America, hydro is great because big, huge, powerful rivers are enough to provide a lot of electricity from hydro stations. So in every country, and Bulgaria as well, of course, it's worth to look at local conditions, local sources of energy and needs, of course. First of all, we should know how much energy this country needs, actually. So it's about Russia, briefly. I guess, anyway, you heard about Russia is big exporter when we're talking about different fossil materials, energy sources, maybe. The upper line is actually referred to Russia inside, not place of Russia in the world, of course, because it's actually position of fuel complex, of energy and fuel complex inside of Russian economy. So it means, first of all, inside of our country, different power plants and cycles, fuel cycles, play very significant role. And if we talk about place of Russia in the world, you see different values on this slide about which place in producer of oil, gas, and so on. So, by the way, I'd like to say that maybe you know about it. Nowadays, when scientists, maybe different specialists, talk about future, what will be in future with energy, with humankind, and so on. First of all, there are three scenarios which could be realized. Inertial, it will be like nowadays, as is. The same number, roughly, of power plants, the same volumes, and so on. Stagnant, it means, as usual, worst case, when there are no new objects, but old objects will be decommissioned. And innovative, it actually means to develop something new, really new sources, significantly improved constructions, and in this way we can go further. And priorities. Priorities in European Union, in different countries. First of all, energy saving. Of course, it's worth to save energy because it's very expensive to get new energy from new sources. First of all, good idea to realize different measures in this field. Environmentally friendly technologies and pure technologies. Not only on stage of operation of plants, but it's very important to talk about this feature for all fuel cycle. And in this way, many renewables not so attractive, really. And use of new sources as the basis of the development. But nowadays, right now, renewables, I guess, a little bit overestimated, because it's not so simple to develop in this way. About technologies of power production, actually, I will go very briefly, because my colleagues from our universities really explained today many points from this area. First of all, if we talk about where nuclear power right now, it's actually for Russian Federation it's generation 3 plus this area, because generation 3 is traditional power plants which were put into operation starting from 90s. Generation 4, it's still now it's just goal. It's just goal according to IAEA docs and so on. It's worth to develop, worth to invest in this area, but there are no one prototype of these reactors nowadays in the world. And 3 plus, it's really working. For Russia, VVR 1200 power megawatts reactor. Nowadays, 4 power units are working inside of Russia, and one more is working in Belarus nowadays. Especially this kind of reactor technology, HackAtom company nowadays provide for foreign customers. And the second country, it's better to say the second company with this kind of technology, it's Westinghouse from the United States. The first AP1000 was put into operation a couple of years ago in China. Basically, generation 3 plus can be characterized by significantly higher level of safety of nuclear power units. And my colleagues from other university from Tomsk said about the safety of nuclear power plants in details today. So on this slide, really, you can find some explanation of basic ideas laid inside of safety paradigm of VVR 1200. So you can see on this slide. Parameters really were announced today about different values. And overall view of primary circuit with all equipment. So about some outside conditions. Outside means refer to society, to economy in some country. About cost, this graph, as I know, refer to Russian situation, and moreover, the situation was, I guess, maybe a couple of years ago. For different countries, of course, different graphs will be plotted anyway, because price of electricity, of course, is different in different countries. And nowadays, I guess you know, it's complicated situation in the European Union, because due to different political reasons, different, first of all, political and economics reasons. And yes, price maybe change differently between different countries, and moreover, price is very volatile. One day, price may be changed several times. And of course, it's very important for every country, because price of electricity, cost of electricity, it's actually, electricity looks like blood, maybe, like some main substance of every economy, because you know, a lot of, maybe not all, but majority of equipment, drives, different facilities all around us really should be supplied by electricity. And of course, all our households, all our homes should be supplied by electricity. So price is different ones. So this part actually is one of central in my presentation today, because after my presentation, my colleague and friend, Mr. Samokhin, will announce together with me task for our participants for this hackathon. And actually, our idea which participants should to pay attention actually to analysis of nuclear among other sources of generation, because it's important, because if you say some source is good or some source is bad of energy, anyway you should to add good or bad according something, because you can say nuclear is better than coal because, and some explanation, but there are no terms about bad or good without any comparison. So about renewables, because nowadays, in Europe especially, general idea, the coal is dirty source, and it's known information, because if we compare, coal in general, of course, will give the main volume of gases, greenhouse gases and pollutants in the atmosphere, at least. So coal is dirty source, but it's some paradox. Nowadays, coal is #1 in power production. Why? First of all, due to its price. Coal is cheaper. Coal is significantly cheaper, especially if we invest nothing in special protecting systems. I mean, environmental protection, like filters, like special equipment to clean gases and so on. So nowadays, many people say about renewables is great, it's worth to develop this area. Hydro really lays around of this discussion, because hydro looks like traditional. Moreover, hydro is the oldest, I guess, more than several 100 years of history. Hydro stations in some way have been used by mankind. And actually, nuclear is new. Nuclear is new source, of course, not so new like wind for modern wind mast or solar, but nevertheless. So some words about nuclear power we can find on this slide. So now I'd like to go through different sources, and to comment pro and contras for everyone. So first one is biofuel. I guess maybe according to alphabet. So biofuel, very popular topic in many countries maybe, but nowadays, of course, as I know, it's not a real alternative for others. First of all, biofuel can be used from different chemical substances like methane, ethanol, hydrogen, and so on. Can be produced from some waste. Waste means from food waste, for example, and so on. So plus is that biofuel produced CO2, which is absorbed by plants, usual plants, and various fuel production sources. But minus is due to formation of gas, the incineration take place, and it's bad really. And to product biofuel, we need to use fossil fuel. So anyway, we should to use usual fossil fuel. Of course, in this way, we actually increase pollution of environment. And by the way, as I know, for biofuel, there are a lot of maybe small problems, but these problems should be solved. Not so obvious nowadays. About wind. From one side, idea to use wind, of course, really the oldest. Not 100, but 1,000 years. If we talk about ships and so on, but idea how to produce electricity from wind energy actually is rather new. To install special mast with propeller or fan on this mast with special generator. So yes, wind blows, this propeller rotates, and generator produces electricity. Great, but actually in real life it's not so optimistic, because about ecologically safe, as I know, not fully, because first of all, nowadays, like on this picture, maybe in Europe, in Germany, first of all, in maybe in Great Britain, a lot of wind masts really are positioned in the sea, not on the sea coast, on the land, but in the sea, because it was discovered that during operation, first of all, wind plant generate infrasound, which is very harmful for human beings around and from animals, and as well as both offshore or onshore wind masts really very harmful for birds, as I know. For birds, because it's some source of damage for them. Unlimited roll source, yes. About this, wind is really unlimited. And if you have some places of country with really strong winds during many days per year, it's a good idea to use this energy. By the way, nowadays to avoid many problems of wind energy, as I know, more perspective maybe source, it's mast of not this type with propellers, but vertical, when our propeller looks like not cylinder, but something like this, other direction. About minuses, about disadvantages, unregulated energy source. Yes, it's very hard to regulate in some way. Wind can be present, maybe not. And it's famous situations, not from now, really, more than 10 years ago, when in Great Britain, 1 week was really with no wind. And in big hurry, Great Britain started to operate old coal plants just to cover this gap between electricity production and electricity needs. Noise level, high noise level. Actually, I said about this when talk about positioning of wind inside of sea. Low physical security. It's hard to protect from not terrorists, but from some bad people. You know, a wind park really occupies huge area. It's very hard to provide some guard for this area, and large areas as well. I just said about this are required. Complexity of blades manufacturing. Yes, and moreover, it's true for wind and for solar. In many cases, when we're talking about pluses of these technologies, we should to keep in our mind that, as usual, advantages are realized during operation, but many disadvantages really are typical for other stages of production, for manufacturing of this equipment and for decommissioning. Because after decommissioning, as I know, in many cases, there are no technologies to not reprocess, but to use in some way all this equipment after operation. But next, solar. Actually, some was the same like for wind. Ecologically safe. If we talk about final product, if we talk about photovoltaic panels or other kind of our layouts of solar plants. But if we're talking about manufacturing, it's not the case actually, because during manufacturing, especially photovoltaic panels, it's rather dirty technology for environment. About unlimited, yes. If we talk about Egypt, I don't know, Saudi Arabia, African countries, Asia, with more than 300, I don't know, 50 maybe days, solar days per year, yes, good idea, a lot of sun. But you know, anyway, every night there is no sun in every country. High cost of solar cells, yes, nowadays this manufacturing should be subsidized by government as usual. Surface of panels should be cleaned time by time from pollution, and in many countries in Africa and Asia, problem is the main problem is sand, because there are sandstorms, and in this way solar panels maybe very quickly will be covered by some layer of sand, and you should to clean in some way. As usual, we need special cooling systems. Service life of elements is rather limited. It's not so many years. and low efficiency. If we talk about efficiency, how much percent of initially available maybe energy can be used in like electricity, this percent not so high. So hydro ecologically safe, I think yes, because anyway there are issues regarding fish in the upper part of a river before them. But as usual, as I know, there are special channels just to provide migration and so on. Anyway, of course, it's some and intervenes inside of environment, but anyway, it's ecologically safe. Low cost of energy production. Yes, just after construction of expensive and big dam, this dam can be used really dozens years, 100 years, very long time. And you will get just money for electricity and you need to spend money for maintenance and repairs. Minuses, flooding of agricultural lands and populated areas. Yes, you lose territory in this way. Water balance disturbance, of course. And climatic effects, because creating of big artificial lakes, of course, will provide some impact on environment. And danger of major disaster. Yes, if dam breaks, it will be really huge disaster for all cities below of this dam along the river. As I know, for biggest, not only hydro, but biggest energy plant in the world, in China, 3 Georges, as I know, on Yangtze River. In case of damages, total damages of dam, I guess it will be maybe millions victims, because very highly populated areas around, so really it's a very risky situation. Geothermal energy, really, it's exotic, I guess. Yes, in Russia is big country. In Russia, yes, in Far East, on Kamchatka, there are special plants when we use thermal energy from geysers, from thermal springs from the ground. But anyway, it can be used only in some specific regions. Hydrogen energy. It's a very hot topic in many countries, how to use hydrogen for car instead of gasoline or benzene in different production facilities. But ecologically safe in clean form, high efficiency and unlimited raw resource, because hydrogen is the #1 element in the universe if we talk about its quantity. But only one drawback, but very, very big one: high explosion hazard. Because yes, everyone knows that hydrogen is very explosive substance, and we should to provide huge efforts just to avoid possible disaster. So about the future of nuclear in this sense, first of all, I'd like to say usual fuel cycle is known, I guess, for you. But first of all, I'd like to say that in Russia nowadays, the state of the art is research, first of all, directed in closing of nuclear fuel cycle. Closing means not to find uranium in the ground, to extract and produce fuel, use this fuel on the nuclear power plant, and then just dispose. It's usual cycle, and in this way, I guess our uranium, usual uranium in the ground, will be enough maybe 200 years. But if we manage to close fuel cycle, it means to reprocess spent fuel, to extract different valuable isotopes and isotopes for new fuel as well. If we can organize process in this way, we can increase time of operation for this technology, for nuclear technology, really for 1,000 years. Of course, we talk about fast reactors in this way. And nowadays, Russia is #1 in the world if we're talking about operational experience. And like fantasy maybe, but not so far really. It's really using nuclear for space, for example, like space engine, because maybe you know traditional sources nowadays for space launcher really achieved I think maybe the highest point, because it's very hard nowadays to improve something, because this technology counts more than, I don't know, 60 years, 70 years. So nowadays mankind needs something new, some new technology just to not just to go on the next, principally next step in this area. So nuclear engine is possible. Moreover, the same Russian Federation has operational experience for nuclear in space. We talk about special satellites, but now we talk about special nuclear engine. And nowadays, Rosatom State Corporation in Russian Federation, together with Roscosmos Agency, really try to construct the first spaceship, maybe with nuclear engine on board. So we have a chance to see, of course, not in a couple of years, but maybe 1 decade, some results. About hydrogen production, on this slide there is information regarding this area from South Korea, from United States. Anyway, idea is to use hydrogen, but nuclear can be used like very attractive technology to produce hydrogen, because for hydrogen production we need, for some technological process, we need high temperatures, and these temperatures can be realized through using of nuclear power plants of special design. So nowadays, the projects of these hybrid constructions are very popular in different countries. And of course, if we talk about like nuclear, but actually it's not nuclear, but thermonuclear, like fusion reactor. Nowadays, ITER project is the top project in this field. This project have been constructed by not only one country, but many countries, like consortium from European countries, United States, Russian Federation, Japan, and so on. And really, if I remember right, in 2025 maybe, these guys say about we provide first electricity, at least from this installation, at least start up and trying to get energy from this facility. And final part of my presentation, I hope to put inside of 5 minutes really, because I know time is gone, about really environmental impact. First of all, on this slide, very interesting values, numbers. Moreover, it's not from Russian agency or something like this. You see source, it's United Nations Environment Program 5 years ago. Of course, in general, in average on the world, in average, every person during, I guess 1 year, world average person in year, will get actually this amount of radioactivity of natural sources, 2.4 millisieverts, and artificial sources, 0.65. You see, first of all, natural sources are many times higher than artificial ones, first of all. And radon gas inside of different materials in the ground is number one. And if we talk about artificial sources of radioactivity, first of all, it's radiology. Radiology, it's like nuclear medicine treatment. And nuclear medicine, really, on this slide, it's nuclear medicine diagnostics. It's significantly lower. So radiology, of course, big values. All legacy from weapon fallout, from Chernobyl, which was realized more than 30 years ago. You see very small values. And from all operating in the world nuclear power plants, for average person, this dose is only this very, very small value. Nowadays in the world, there are more than 400 power units in different countries. And on this slide, you see some comparison between the most popular coal, gas, and uranium. Numbers, how how much electricity can be produced from combustion of ton of coal, for example, combustion of gas and so on, and fission of uranium. Moreover, for fission, it's realistic values, because in many sources you can find like theoretical threshold. If we can fission all uranium, every nucleus, we can get this electricity. No, in this case we talk about real fuel, 5% of enrichment, and with keeping in mind that in spent fuel some uranium stays after operation and so on. So first of all, huge difference in electricity and difference in emission of different gases. For nuclear power plant, this emission is zero, really. On this slide, some numbers from International Energy Agency, emissions from fuel combustions, and comparison between 1973 and 3 years ago, changing of shares between, and changing in emissions, really twice. And energy sources and greenhouse gas emission, but for all life cycle of different sources, because green is average emission intensity, but range between studies really. First of all, for example, for solar photovoltaic panels, we talk about small emission during operation and so on, but if we take into account emission during manufacturing of these panels, you will see several times higher. For nuclear, of course, you see small value for operation and bigger for all cycles, because anyway, during construction of nuclear power plants for 5, 6, 7 years, of course, a lot of trucks will be used on the construction site. Of course, we will exhaust some gases and so on and so on. But after this, after completion, during operation, the only one effect on the environment, it will be thermal effect, because we need to take water to cool condensers of turbine outside, from cooling towers, from special basins, from artificial ponds, and of course, warm water after condensers will be returned back. And in this way, we have some microclimate around nuclear power plants. It's not so great, maybe anyway. It's some impact, but not so bad like others actually. So nowadays we can say about nuclear energy really is green energy, and maybe you heard about this. I don't know about results, but really several weeks ago in the European Union, it was initiative from, I'm not sure, an energy commission or some organization to state that nuclear really is green source and among the renewables, because of course nuclear is not renewable, because uranium is fossil fuel as well nowadays. But if we talk about green, yes, it's green as well as all others which form so-called green square, because we have 4 main sources, green sources: wind, hydro, solar, and actually nuclear the same. So my idea during this presentation that really nuclear nowadays it's technology which has significant operation experience, and of course this technology can be used just to get clean, stable electricity production in many countries all around the world. So thank you very much for your attention, because I know it's time to go to task announcement. So if you have some questions, please.
Thank you very much for the interesting presentation, Alexander. Please, now it's open for the questions. Everybody can ask and type his question.
If you are not so tired yet.
A lot of people are typing, so
yes,
we should wait a little bit.
Yes, it's optimistic, but there are some questions.
First question is coming from Adrian. Do you think that the future of nuclear power will become a convenience or necessity? Very
About
interesting question.
yes, about convenience, I guess for some countries it's a real fact nowadays. Because in France, if France get more than 70% from nuclear, it's really convenience. And moreover, as I know, a lot of nuclear power plants really located in Loire Valley and so on, near some castles, near some landmarks. So it's for them it's normal. For some countries, yes, it's something specific, something exotic, and so on. About necessity, I don't know, because necessity, it means you have to use. It's not your wish, but you have to use this source of energy. Of course, I guess it will depend on really our climatic changes, because you heard different reasons, different theories about global warming, for example. Some professors say it's terrible situation. It's very dangerous for mankind. We should decrease temperature and so on. Some very famous professors say vice versa. No problem. It's new ice age coming, so it's just normal. Please wait for a while. So I don't know where is the truth really. For Russian Federation, it may be not so big problem because our country is cold enough. If it will be warmer, it maybe will be better. I'm not sure, of course, totally. So necessity, I don't know, maybe no, because anyway, I'd like to add my idea. Of course, not to consider nuclear as panacea for everywhere, for every situation. I guess for every country, you should to provide analysis which set of sources is better for your country. Because anyway, good idea not to put all eggs in one basket, because very different situations. So it's better to have some reserve anyway. So I think for these questions, my answer.
Okay. Thank you very much. Another question from Ivan. Do you think that once we master nuclear fusion, this will be the major energy source in the future?
I'd like to say, I hope so, really. Because theoretically, yes, it looks great. It looks great idea, but maybe you know this comparison between discovering of usual nuclear fission, and discovering really 1930s to use in military purposes. Actually, it was 40s during World War II and after this, and to use for civil applications starting from 1954, really very rapidly, really couple of dozens years, and that's all. But for fusion, not the case, because as usual for people, to use something in the wrong way, it's great. Thermonuclear weapon was constructed in the United States and Soviet Union in 50s, and nowadays it's known technology for military application. But for fusion, yes, when we're talking about how to use in civil application, really, first tokamaks, as I know, were put into operation in Soviet Union really in 60s maybe. Really, 60 years ago, the first installations were put into operation. But nowadays, we have no success story just to get electricity from this installation. But of course, my wish, my hope, yes, to see. I'm not sure about 50 plus years, especially for me. I'm not so young, actually, but I hope so.
Okay, thank you very much. And the last question from Nicole. She's entering for the first time, asking question. If the ITER project becomes secure source of energy, will be any harmful emissions?
Actually, I'm not so deep specialist in fusion installations, because maybe these installations are significantly different. If we talk about not physics, but engineering solutions, because solutions, how to get energy from this installation, because physically it's understandable, but how to realize in construction form, I'm not sure. About emission, I think no, because I guess there are no sources of emission for fusion. Yes, so yes, fusion should be clean source of energy, but
Okay.
I think anyway nuclear can be alternative for many areas like, I don't know, like space, like transport installations and so on.
Okay, okay. Thank you very much. Thank you for the interesting presentation. And so you covered almost all topics related to the energy application. So the final time comes. Now
okay,
let's...
Slamen, please. Now, thank you very much once again for my presentation. I think you can close in this position. Now I'll go to Mr. Samokhin in his room, because actually we are on the one floor, and we will go to announce of task, I guess.
Okay, okay. Let me finish until you are passing microphone. Let me finish because please. I should announce that time is coming for the giving the task. The most important thing while we are together here now today. So you are passing microphone. I am telling what is coming. Okay, people. Now is the task which student, university student, high school student will receive. And they should solve for 24 hours. Please, Dmitry Samokhin will present the task. Dmitry, microphone is yours.
Thank you very much. Dear students, dear colleagues, and we prepared so interesting task for you. And now, dear colleagues, please give me permission in open my screen. Yes, thank you very much. And I open full screen monitor, and because I prepared simple exercise for you. And dear students and dear colleagues, please write symbol plus in our chat, for example, like this. If you don't sleep, wake up and see my screen. Dear colleagues, dear participants, please. Yes, thank you for your feedback. Ivan, Angel, Andrian, Christian, and others. Thank you for feedback, because you understand it's so important for all professors and other participants. I talk with you offline regime, but if nowadays we unfortunately have a coronavirus situation, and so important feedback from your side. And when I think about how explain for your task, I was not sure about include this picture on my screen monitor or not, because we have a exotic task, and I think many of you will have your own opinion about how realized our task. But in any case, I think this picture will be help us. And we have a next idea for our simple task. And our task dealt with nuclear technology, because how I understand, and we prepared a different lecture, and all lecture have a nuclear application, and not only nuclear application. And our main idea this task for each team idea include next. Each team must prepare something, and I explain now what is it. And this is a product result work this team will be include information about different source of the energy. And for example, you may thought about if we go to preliminary school and we want, for example, involve young generation in a nuclear sphere, and how you may explain about nuclear energy, and nuclear energy, this is so important for us, and why this is important, and how we may save our world for future generation. And our main idea for each teams must prepare it like a quiz. It's maybe not like a real quiz, and like a computer program software. And for example, it's not so easy sit on the computer and directly start preparing software. And first of all, you must design like a block diagram for it's must looks like algorithm your program. And one of the example here you may see another example here, and final result your work. You must prepare three document, three parts. First of all, this is a block of diagram, and this block of diagram must include your opinion about step-by-step realization your computer program software. And this diagram must include a question, maybe simple task, maybe a picture example, for example, comparing nuclear energy and wind source, and a picture with nuclear power plants or experimental reactor, and a picture with other electrical equipment and others. And during your final presentation tomorrow, you must use your own scheme, your own block diagram.
Dmitry, sorry for interruption for a while. Somebody cannot see. Miroslav is saying that he cannot see the screen.
I think it's just for Miroslav, because I see that he's joined with from his mobile. So
okay, sorry.
Computer, or maybe he just minimized the screen.
Okay. Mobile is different story. Okay, sorry. You should find nearest computer.
Yes.
Or okay. Sorry for interruption for this, Dmitry. Please to continue.
Okay, because in the previous time I asked add a symbol plus if our participants hear me and see screen monitor, and many of our participants write symbol plus in our chat. It means everything okay. And repeat again. First result to work. Each teams must prepare a block of diagram, and you may realize a block of a diagram in a PPT format, or for example Vision Studio, or for example draw by your hand and make a photo. But your block of diagram must be so clearly understandable for jury, and step-by-step question, and maybe return for a previous level and ask again and other direction, and next. Second result, this is a real application developed by the team in different software complex. For example, you may use C++, Delphi, Python, or maybe one of the internet application, I don't know. And it's depends of you. It's maybe mobile application.
Is it Java allowed?
Yes, it's a decision from the team.
Okay. Everybody is free to use whatever he likes.
Yes. It's depend of the team and decision this team. And third result, this is for example, this is how it looks like the diagram, and how may looks like application and result work application like this, for example, like a quiz, like other view, for example. And last part, this is a open code development application. If you use your own code, you must drop this code to jury. And of course, for example, if you realize HackAtom and this idea in like internet instrument, for example, and of course internet one of the software not have an open computer code, and this case you will have only block diagram and applications software. And for example, other team make your own decision and use own computer application program code. And of course, if we will choose between this and their teams, we will choose the team which use open computer code. And one of the important moments, your final result must include the quiz, question, photo, and step-by-step explanation dealt with not information not only about one or maybe two sources of the energy. Your final result must include information about nuclear energy, sun, wind, biofuel, and how, for example, my colleague Alexander Nahabov explained for you 20 minutes ago. And if you listen correctly, a lecture, my colleague, he explained plus and minus parameter, all kind of the primary source of the energy. And of course, you may use this information. And of course, you have an open internet resource. You may open a different website, and I don't know, and Google and Yandex and Rosatom website, and maybe different other resources. But all information about all this primary source of the energy must be included in your final result. Sun, wind, biofuel, fossil fuel, nuclear fuel, and maybe other type of the fuel. And maybe one more point here. Each team have your own decision about how this team will be work. For example, you may sit in one room and during one day prepare on your final result. And for example, you, of course, and nowadays we have a pandemic situation in all the world countries, and you may sit in a different part a country and work together due to online tools. And you may use a different operation system, for example, Microsoft Windows, Mac OS, Android, and others. It's depends of you. And important moment dealt with part number 2, your final result. This final result must include exe file. And when you dropped all this information, and important moment, you must drop this information before start our final session tomorrow. I think it's 2 p.m. Sofia time. 2 p.m. Sofia time. Dear colleagues, it's a
according to information that I have, start of the presentation will be 3 o'clock.
Yes, and we start exactly this presentation, but all team must load your final result before start. Okay, it's maybe
where they should load
it. Maybe will be just in time, for example, before 3 p.m. of Sofia time. And okay, I may drop my Gmail right now. Just a second.
So you will provide your Gmail space for the where they should upload their results.
It's will be my own Gmail, own Gmail, and whole team.
Okay, Dmitry, there is some important point. You said that they should provide some executable file. If you provide the email, most important, the antivirus will remove any executable attachments, including even if they are archived. The best way is to provide space on Google Drive or something else. So,
yes, I understand, but we have the same situation in the previous time, and the team may all 3 point include in the zip file, load inside the cloud, and drop for me a link on this mail. And I upload this information on my computer, and it will be like I don't know. It's like our safe moment. It means other team not will be include information if for example first team will be presented your own result, and last team, for example, during 1 hour may be use simple idea or something else. And if this team add this information in your own slides, we will check, and if this happens, we will have a minus point for this team.
Okay, this work of the uploading should be done until 2 o'clock, right? Bulgarian time.
Yes.
Okay, 2 o'clock p.m. All student team should send to you on your email archived version of their answers to your question.
Exactly.
Okay, later you will upload this on some cloud, so everybody could see their solutions from there, right?
Yes, right.
Okay. Another questions. I have several questions. The second question is, you mentioned they should provide some executable file, but you mentioned that they can use any tool. So some tools do not provide executable file. They just use, they just provide script, and this script can be run by something else. So in this case, you will have the proper tool to run this script, or you will not expect to run it. In this case,
I think it's the best idea if all information will be in PDF format. What I mean.
Okay.
First block of the schema, the PDF format, and text of the program must be in the PDF format too, and one of the exe file, for example. And exe file, of course, start to work in different system.
Okay. if such file exists in this case, I understand.
Yes.
Okay, another question is, we watched your task, we heard your explanation. Could you provide the original document where task is written, your
Yes,
file?
It's possible. For example, I dropped this file to.
Can you send to Icona Communications and they will distribute among the.
Yes, I don't know. Alex Fayalov here now. Alec, do you hear me? Because I dropped this file to Alec, and just a second. I don't know. It's a possible drop right now in our chat. This file.
Okay. Okay.
Just a second.
No, it's not possible.
Not possible. Not
Yes.
possible. If you, for example, I saw the Nina.
Okay, Nina provided email, so
Yes,
you can send it to her.
just a second, I drop immediately. I drop immediately this file to Nina. Just a second, please give me 1 minute.
Okay. Another question is, I know that you've already provided lectures.
Yes, I dropped file right now to Nina. Nina, please check your mail and
Okay.
let me know if everything okay.
It will be allowed students to use the lectures from today to answer the task.
Of course, it's
Okay.
Maybe the best idea. And one of the moment, it's I think, if, for example, one of the team, it's not the students, and I know maybe one of the team from a preliminary school, it doesn't matter. Please try preparing block scan. It's maybe if it's not so easy for you prepare an exe file or software, doesn't matter, everything okay. But please prepare it, for example, only one point, a block scan.
Okay. And the last question, maybe also they should provide short screens, print screens of short screens of their computers if their program is running, how the program is running. Students, like third point, they should provide the block scheme, the text of the file, executable, and finally some short screens of the how it's running their program and their computer to avoid some problems with different operating system or so on. Maybe that would be also a good idea.
Yes, it's a good idea. But for example, if we will have two teams with the same result, and all teams presented the screen, show, and others, of course, we will must do the final decision, and we will check this file.
I think this is quite unlikely because we have ruled that each team works independently, so two teams cannot copy to use the same results. So, another question, another questions that I would like to ask is also, will be there presentation, or you just will look at the results and announce your decision? Each team will perform presentation of their results, like last year. Will be presentation on the results.
I think a presentation will be the best decision because presentation include step-by-step slides and step-by-step explanation. But if one of the team doesn't like presentation, and this team, understandable, they may use some other application and other technical decision how this team may present your own result. It depends on the team.
Okay, so presentation is welcome, but not requirement.
Exactly. Exactly.
Okay, so in this case, we should finish our online session. Each team will receive by email the task. So I also will provide my email address in case if somebody is not received yet.
Mm-hmm. For example, at this moment I dropped information to Nina and to Alexander Mikhailov, and this moment I drop a PDF file with task to Alexander Georgiev.
Okay. 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 I also will distribute among the people from the teams from Sofia University. I hope that every responsible person from particular institution will distribute among his students. So I think this is enough to send to Nina.
Okay, that's all I think.
Now the last question, yeah. the very last question. If some of teams has questions, how they can access you to ask their questions?
I think team may use my WhatsApp, and
please type your WhatsApp address.
Just a second, I think it's maybe a better decision from WhatsApp.
I think everyone here has WhatsApp.
Yes, yes, it's WhatsApp. Just a second.
Maybe Viber if you have.
The same. Telegram or WhatsApp, it's more successful using WhatsApp.
Oh, okay. Fine.
This is my mobile phone, and please drop a message.
Okay.
Don't call in the night.
Don't call. You may call, but I switch off the phone.
just send messages. Okay.
Okay. Thank you.
Okay. I think that's all. Just teams will receive the task, and approximately the starting will be 3:30. I think the 3:30 will be official announce starting of the solving of the problems. We'll allow 30 minutes to distribute the documents, lectures, to discuss some technical questions that they have. I should remind the rules of the competition. First rule, it is every team works independently. They could work online, offline, doesn't matter how. They work to the corresponding department, and they choose how they should distribute, how they should present their solution, by presentation or just to upload the materials. Slightly remind the materials that you need to present. This is the block scheme. Should include their text document, the best in the PDF, which include their program, executable file in the zip format, I think, and that's the whole document they should present. So, okay, that's all, I think. Good luck to everyone. Tomorrow, 3 o'clock, back, we will see the results. The time for the competition ends 2 p.m. tomorrow afternoon. Okay?
Okay, thank you very much. Bye.
Thank you very much for the nice presentation. Thank you very much for the very interesting task. It's very challenging. I would like to be 30 years younger to join the teams.
Okay.
Okay.
Yeah.
Bye.
See you tomorrow. Bye.
See you tomorrow.